Ever wonder what lies beneath your feet, deeper than anyone has ever gone? Imagine digging a hole that never ends, breaking through mysterious layers of Earth, breathing extreme heat, pressure, and molten rock. Could you reach the planet's core, or discover unimaginable secrets buried deep below? Well, let's unearth the possibilities. At first glance, digging a hole seems like a straightforward task. Soft soil, scattered roots, a few small rocks meet the shovel's blade. The surface layer, called topsoil, is home to plants, insects, and organic material, a vital layer for sustaining life. But as the dig progresses just a few meters down, subtle changes begin to emerge. Temperatures start to cool temporarily as sunlight and the surface heat diminish, but soon the ground begins warming due to geothermal energy seeping from below. The soil gives way to denser material, layers of compacted rock and sediment formed over millions of years. Eventually, digging would bring you to the Earth's crust, the planet's outermost and thinnest layer. Ranging from about 5 kilometers thick under the ocean to up to 70 kilometers thick beneath mountain ranges, the crust is surprisingly shallow compared to the Earth's total diameter of 12,742 kilometers. It's made of solid rock, including granite and basalt, interspersed with valuable minerals and ancient fossils. Despite its relative thinness, this layer is formidable. Drilling into the crust becomes increasingly difficult due to its density, extreme heat, and pressure. Even the most ambitious human attempts, like the Kola super deep borehole, have only scratched its surface, reaching 12 kilometers, far short of the crust's deepest reaches. The deepest human endeavor, the Kola super deep borehole in Russia, reached a staggering depth of 12.2 kilometers specifically. Yet this is just a scratch on the surface, literally, barely only 0.2% of the Earth's diameter. The challenge faced by the teams were immense. The drill encountered temperatures of over 180 degrees Celsius and pressures that caused rocks to behave unpredictably. Despite cutting-edge technology, progress slowed and the project was eventually abandoned. Still, the borehole offered fascinating insights into the Earth's crust, such as the discovery of water deep underground and 2 billion-year-old fossilized microbes. Let's talk about beyond the crust, entering the mantle. If the impossible were achieved and the crust is pierced, the next layer to be encountered would be the mantle. The mantle makes up of about 84% of the Earth's volume and stretches from the crust-mantle boundary, known as the Mohorovicic discontinuity, or MOHO, to a depth of 2,900 kilometers. This layer isn't solid rock as we know it, rather it's composed of hot, semi-solid material that flows over time. The mantle, Earth's largest layer, sits just below the crust and extends to a depth of about 2,900 kilometers. Temperatures here can range from a scorching 1,300 degrees Celsius near the crust-mantle boundary to over 3,000 degrees Celsius closer to the core. The heat originates from 2 primary sources: residual energy from the Earth's formation billions of years ago, and the radioactive decay of elements like uranium and thorium. These extreme temperatures cause the mantle's rock to exist in a unique state. Though technically solid, the intense heat and pressure make the rock pliable, behaving more like molten plastic or a slow-flowing fluid over geological time. This peculiar state of the mantle is vital to the Earth's dynamics. Convection currents within the mantle slowly churn, moving heat towards the surface and driving the movement of tectonic plates. These massive slabs of crust interact at their edges, creating geological phenomena like earthquakes, volcanic eruptions, and the formation of mountain ranges. Without this constant activity, Earth would be a geologically stagnant planet, incapable of supporting the dynamic processes that shape its surface. Digging into the mantle would be a monumental challenge. The material behaves unpredictably under drilling conditions, too viscous to flow easily and too tough to fracture efficiently. It would be akin to cutting through an ocean of caramel, an environment neither solid enough to support machinery, nor liquid enough to navigate easily. But the Earth's heat, where does it come from? The deeper the dig, the hotter it gets, and the increasing heat comes from 2 primary sources. First, the Earth retains residual heat from its violent formation over 4.5 billion years ago, when colliding planetesimals released immense energy. Second, radioactive decay within the Earth's interior generates heat as unstable isotopes like uranium-238 and thorium-232, and they release energy. Combined, these factors turn the Earth into a natural furnace, with temperatures increasing by about 25 degrees Celsius for every kilometer dug. Now, what about facing unimaginable pressure? Because while the heat is a significant challenge, pressure presents an even greater obstacle. At just a few kilometers down, the weight of the overlying rock becomes immense. By the time the mantle is reached, pressure reaches millions of times atmospheric levels. This extreme force causes materials to behave in unexpected ways. Rocks that are brittle at the surface become ductile, folding and flowing like putty. Tools and drilling machinery would need to withstand conditions that no material on Earth can currently endure. A journey to the core, specifically the outer core, because at a depth of around 2,900 kilometers, the mantle gives way to the outer core, a layer of molten iron and nickel. This metallic ocean, with temperatures ranging from 4,400 degrees Celsius to 6,100 degrees Celsius, is in constant motion. These swirling currents generate the Earth's magnetic field, a protective shield that blocks harmful solar radiation. Without this field, life on Earth might not exist. Digging through the outer core would pose incredible challenges. The liquid metal would be nearly impossible to contain or drill through, and additionally, seismic data shows that the outer core is extremely turbulent, with flow patterns changing over time. Beneath the outer core lies the inner core, a solid sphere of iron and nickel about 1,200 kilometers thick. Despite temperatures hotter than the surface of the sun, the inner core remains solid due to the immense pressure, which forces atoms into a tightly packed structure. This solid core is crucial to the Earth's dynamics, helping stabilize the planet's magnetic field and contributing to its overall structure. Interestingly, the inner core rotates at a slightly different speed than the rest of the planet. Recent research suggests that it may even have a layered structure, with differences in how iron atoms are arranged. This enigmatic region remains one of the most mysterious parts of Earth and is entirely inaccessible to direct observation. Now, why can't we dig deeper? Because given humans' technological advancements, why hasn't anyone drilled deeper than 12 kilometers? The main limitations are heat, pressure, and time. Current drilling technology, even with advancements in cooling systems and reinforced materials, can't handle the extreme conditions found deeper than the crust. The Kola super deep borehole, for example, had to halt progress as temperatures made it impossible to continue safely. Additionally, the scale of such a project would be astronomical. To dig even 1% out of the Earth's diameter would require vast resources, unprecedented engineering feats, and decades, if not centuries, of effort. The financial and environmental costs would be enormous. But what happens if you reach the other side? Let's imagine for a moment that it was possible to dig a tunnel straight through the air from one side to the other. Gravity would play a fascinating role in such a scenario. As the dig progressed, gravity would pull downwards, but upon reaching the core, its effects would cancel out. Essentially, at the very center of the Earth, a person or object would experience weightlessness. By studying seismic waves, developing geothermal energy, and exploring the planet's depths in other ways, humanity continues to learn more about the incredible world beneath our feet. If the mysteries of the Earth fascinate you, then consider subscribing for more deep dives into science, exploration, and the wonders of our planet. And don't forget to share this video with fellow curious minds. And leave a comment below what are your thoughts on what lies beneath the surface. The journey to understanding our Earth is just beginning.